Today's session is about making an automatic gardening irrigation system by using Bolt Wi-Fi module. Okay, let me introduce myself. I'm Jack, Board member, pursuing an agriculture engineering in Excel Engineering College at Tamil Nadu. I have basic knowledge in stack web development and some computer languages and IoT platform. These are the topics we are going to cover in this session. First one is an automatic irrigation, basic intro for Wi-Fi module, material circuit for making an automatic irrigation system, making of circuit connection, explanation about Wi-Fi setup and coding snippet, and lastly project demo video. Okay, let's see an introduction for an automatic irrigation. The automation of irrigation system has several positive effects. Once installed, the water distribution on fields or small-scale gardens is easier and does not have to be permanently controlled by an operator. There are several solutions to design automated irrigation systems. Modern digital systems allow big areas to be managed by one operator. Single irrigation, drip irrigation, or subsurface drip irrigation systems require pumps and some high-tech components, and is used for large surface field operators are also looking. Basic intro for Wi-Fi module. The number of devices connected to Internet of Things is growing exponentially each year. This is being driven by multiple factors, including the availability of Wi-Fi in consumer homes and workplaces. The falling prices of Wi-Fi connectivity and consumers expecting more and more of their devices to be controllable using apps. Fundamental to this IoT adoption is connectivity, specifically Wi-Fi modules and chips. So, when developing our own IoT project, it's critical to determine which is the best IoT Wi-Fi module for you. Therefore, we are going to discuss what we need to consider when making your choice. Bolt Wi-Fi. Bolt is a combination of hardware and cloud service that allows users to control their devices and collect data in safe and secure manner. It also can give actionable insights using machine learning algorithms. The hardware modules in the Wi-Fi chips with a built-in 80 MHz 32-bit RSH CPU that operates at 3.3 volt. It also works on an interface for a set of sensors and actuators through GPIO and UA architectures to collect data and react with it.
Excuse me, Jagat. Sorry to interrupt. People are not able to hear you. Could you please bring your mic little closer?
Okay, bro. Can you hear my voice?
Guys, write in the chat box if you can hear him well.
Okay, bro. Material circuit for making an automation. The first one is boost converter, bolt Wi-Fi module, and two buck converters in different voltage rating. One phase step down transformer and full wave rectifier. 2 to 12 volt mini solenoid gearbox. It based upon your need. The next slide we will see the short specification about these circuits. First, we see about the functions of buck and boost converter. The boost converter is one of the simplest type of switch mode converter. As the name suggests, it takes an input voltage and boosts or increase it. All it consists of is an inductor. This is an inductor and a semiconductor switch, a diode, and a capacitors. Also need a source of a periodic voltage. A buck converter is a DC to DC converter that efficiently converts a high voltage to a low voltage efficiently. Efficient power conversion extends battery life, reduces it, and allows for smaller gadgets to be built. The buck converter can be used in lots of food applications. And these are the second major components for our project. A step-down transformer is a device which converts high primary voltage to a low secondary voltage. In a step-down transformer, the primary winding of a coil is more turns than the secondary winding. Transformer works on the principles of Faraday's law of electromagnetic induction. How a solenoid valve works in controlling the flow of liquids or gases in a positive, fully closed or fully open mode. They are often used to replace manual valves or a remote control. Solenoid valve functions involves either opening or closing an orifice in a valve body, which either allows or prevents flow through the valve. A plunger opens or closes the orifice by raising or lowering with a sleeve tube by energizing the coil. This is a both Wi-Fi module and bridge rectifier. Many electronic rectifier DC power supply to power various electronic basic components from the available AC main supply. Rectifiers are used to convert AC power to a DC power. Among these rectifiers, a bridge rectifier is the most efficient rectifier circuit. We can define bridge rectifier as a type of full wave rectifier that uses four or more diodes in a bridge circuit configuration to efficiently convert alternating current to a direct current, that means AC to DC. Finally, this is a 3-volt relay module and 12-volt DC pump. We must know what the relay is and how it works before we use it to power high voltage devices. The relay module is an electrically operated switch that can be turned on or off, deciding to let current flow through or not. They are designed to be controlled with low voltages like 3.3 volt like ESP32, ESP8266, etc. or 5 volt like your Arduino. DC powered pumps are the direct current from motor, battery, or solar power to move a fluid in a variety of ways. Motorized pumps typically operate on 6 volt, 12 volt, 24 volt, or 32 volts of DC power. Solar powered DC pumps use photovoltaic panels with solar cells that produce direct current when exposed to sunlight. Making up circuit connection. This is the circuit diagram of making a connection from step-down transformer to full-wave rectifier or bridge rectifier. Before ensuring that we don't connect a transformer with electricity supply during this circuit connection. After finishing step 1, we have to make a connection for each circuit separately. Don't be confused. Don't be confused. I will explain it clearly. Once the bridge rectifier is connected with a step-down transformer and connect a separately 5-volt buck converter and a 12-volt buck converter and two 5 to 12-volt boost converter parallel to the bridge rectifier. When we connected all the converter circuit to bridge rectifier, first we have to connect a supply pin and ground pin of the board module to the 5-volt buck converters to output pin and connect the 3 buck and boost converters to a 3-volt relay module on a mainline pin which is located in a relay module and connect a coil pin of relay to Wi-Fi module GPIO ports by using jumper wires. Each relay connected separately with GPIO pins of both module using jumper wires connect a relay output port to 12-volt pump, and connect another two relay output ports to the 12-volt solenoid valve. This is a pipe connection for our automatic irrigation system. Connect a water tank to pump inlet hole with the help of tubes. From the pump outlet divided into two connections and place a solenoid valve in the irrigation tubes. And finally, connect a micro or button irrigation tube to the outlet of the solenoid valve. These are the steps for making a circuit and pipe connection for an irrigation system. Explanation about Wi-Fi and coding cipher. I think you have an idea about a circuit connection. There is a little doubt about how to connect a Wi-Fi module to the internet and how to program a circuit. Don't worry, I will clarify this doubt now. Install the Bolt IoT app on your mobile for making a connection to the cloud through the internet. Once you install it, follow the instruction which it will display on the app. Once you purchase the Bolt IoT product, you are eligible to access the tutorial section for IoT. So don't be worried about learning. It's so simple and easy to understand all the topics of IoT. Bolt product setup. Visit Bolt website and sign in with a purchased account. Once you get signed in, you will go to the Bolt dashboard. Visit product option to customize those settings. This slide shows the picture of the product option. The code option to program a Wi-Fi module for your needs. This is my coding snippet for my module. In this code, I created two graph and three buttons. Each buttons are combined by two options, one for on and another for off. I will one by one in the next slide. These are the result of my code. In this, I created two graph module and on off buttons for pump and two gate valves. And on off buttons for pump and two gate valves. This is my project demo. Come on, let's watch a demo video of my project. Okay, I'm going to teach a coding stepper when I'm programming for the irrigation, automatic garden irrigation. The, the note is visible. Okay, this is the coding snippet I programmed for my automatic irrigation for gardening. First of all, you, you have to include a histogram graph and you set a chart type. I used stepped graph for my project. And second, you have to set a axis name, which I denoted time and data. And then you can plot chart, timestamp, pump, and gate one and gate two, which I give in my module. Next one is a second graph. I choose a scattered graph and set a axis name, time, and data. Plot chart. This is the module port which I named as a timestamp pump and gate one and gate two. And the third one is a dual button. I have choose a dual button for on and off. Um, and I choose the background color black and shape is a rectangle aligned to the center of and text color will be white. And I choose the second button, which is the background color is yellow and shape rectangle. And I center the button and text color will be a black and the value is being low, which is return 0. And the second one is then and the third button is for gate 1, which is then value is high and background color is black and shape is being rectangular. And this also I'm going to be center this button, text color being white. And this fourth button is for gate 1 for off. This value is being low and the background color is yellow, shape rectangular, and this is also being center and the text color is being black. And this is an fifth button, which it is named as an gate to on and value is I. Background color I choose black and shape is rectangular and I center this button. Text color is being white. And this is the last button which I named as a G2 off, which means gate to off. And the value is being low. Background color is being yellow and shape rectangular. And this also I'm going to center. And text color is being black. Thanks for giving this opportunity. A special thanks for both team and participants. Okay, this is the query times. You can ask doubts about this project now. If you are feeling inconvenienced to ask a question, just text a query in this meeting.